Hello, my name is Paul Johnson, a Senior Solutions Architect with Amazon Web Services. Welcome to my talk today entitled Energy Bill Prediction, otherwise known as Alexa, Predict My Bill. Recent statistics show that 1 in 5 American households are behind on their utility payments. Receiving a surprisingly high bill at the end of the month can be a very stressful event for a customer. Now, utilities do provide some consumption information on their public websites, but the data is typically lagged and does not really provide cost information to the consumer. Some utilities offer high bill alerts, but the customer still does not know the extent of their problem until they open that final bill. So on this slide today, I'm showing you some typical reasons that customers can get surprised by a high bill. So what's a solution we can offer? Well, millions of internet-enabled households have Alexa devices. These devices provide a dialogue by which a customer can ask basic questions such as how much electricity have I used this month, how much did I use yesterday, or predict my bill, and others that the utility may choose to provide. And this is what the architecture looks like running on AWS. At the beginning of the month, we produce a daily kilowatt-hour forecast using one of our machine learning forecasting tools, such as Amazon SageMaker. Billing determinants, such as the rates being charged and the billing cycle dates, are loaded directly into our NoSQL database called DynamoDB. Throughout the month, then we ingest the daily meter reads into Amazon S3 and pass them also into DynamoDB. The customer can ask questions about their energy usage and predicted bill on their Alexa device. This can be an Amazon Echo Show or even the Alexa app on a smartphone or in their car. DynamoDB becomes the one-stop shop from which the Alexa skill fetches the necessary data to provide the response. A serverless Lambda function provides the business logic needed to calculate the bill. Now, the authors experimented with various algorithms and approaches to predict kilowatt-hour consumption over the past 2 years. Statistical algorithms such as ARIMA provide a reasonable prediction, but cannot be enhanced with temperature information and other features. Overall, the DeepAR algorithm has provided the best model performance for this type of time series prediction. Seasonal variations due to air conditioning and heating loads are detected by the DeepAR algorithm. Now, of course, AWS cannot guarantee your model's accuracy, but by using the approach shown here, the authors observed 90% or better accuracy on a full month prediction of kilowatt-hour sales at his individual household. This is what a daily forecast of kilowatt hours out to the end of the billing cycle looks like. Advanced machine learning algorithms such as DeepAR are used to make the predictions. We use the middle line, or the P50 line, for our kilowatt-hour predictions, while the upper and lower lines show the maximum or minimum expected values you might see on a given day. AWS offers 3 options for producing this type of forecast. Amazon SageMaker is our ML platform that provides all types of machine learning predictions and algorithms. This is typically used by data scientists. There's also a no-code solution called Amazon SageMaker Canvas that is typically used by talented business analysts who may not know all the details of the machine learning lifecycle. A third option is Amazon Forecast, which is specifically designed for time series forecasting and abstracts away some of the heavy lifting details. For bulk predictions at the individual meter level, Amazon SageMaker is likely the best option, but we want to make you aware of our other options that you can consider using. This view is from our DynamoDB database, and this shows the various rates and factors that get multiplied by the expected kilowatt-hour consumption to predict the bill. Now, this is a simple rate design. Now, if the utility is using time of use rate design or more complex tiered rate designs, much more information would be required to calculate a projected bill. And this is an example of how an Alexa skill is constructed. In this case, the customer's intent is to check on their kilowatt hour consumption from yesterday. The utterances indicate different ways the customer might ask the question. Note that the customer's questions do not have to match this list exactly. Machine learning techniques are used to successfully gauge customer intent based on approximations. The Alexa skill invokes a lambda function that will calculate the prior day usage and the associated cost, which is spoken back to the customer in a response. Okay, here I'll demonstrate the skill. Note that I'll stop in the middle so you can see how the device responds when it gets silence from the user. Alexa, open Predict My Bill.
Welcome to the Energy Bill Predictor. You can say things like, predict my bill, how much did I use yesterday, or how much have I used today?
How much did I use yesterday?
You used 59 kilowatt hours yesterday, costing about $7.
How much have I used today?
You have used 25 kilowatt hours so far today, costing about $3.
Predict my bill.
Your predicted electricity consumption for this month is 1,525 kilowatt hours, and your estimated bill is $184. Do you require further assistance?
What else can I ask?
You can also say things like, how much have I used this month, or what is my average bill?
What's my average bill?
Your average bill over the past 24 months is about $164.
How much have I used this month?
You have used 98 kilowatt hours so far this month, costing about $10.
Alexa, exit. And that's how the skill works. Now, here are some of the benefits of a solution like this, helping the utility, its customers, and society in general. Customers who care about their consumption, whether for cost or environmental reasons, need an easy, intuitive way of obtaining this information daily. The Alexa service provides one additional way for utilities to provide omni-channel customer engagement. AWS also offers a quick start solution for meter data analytics, which can dovetail nicely with this solution since the meter read data would be housed in AWS. The analytic power of the solution can help energy advisors work with individual customers to help reduce their consumption. We have a separate presentation on meter data analytics at this conference, so please let us know if you're interested. So this completes my presentation today. I'd like to thank you so much for your time, and if you have additional questions, our contact information is shown on this closing slide.